The first level of RAID is RAID 0. For RAID 0, it requires 2 or more disks. The data are stripped across the available disks. RAID 0 does not include any redundancy or backups. If it's just one of the disks fails, then all the data will be lost. Therefore, higher the number of disks used, higher the possibility of disk failure and data loss. However, the performance of RAID 0 is very high for both read and write. Next, we go to the RAID 1. For this RAID, it requires 2 or more disks. RAID 1 differs from RAID 2 through SIS in how redundancy is accomplished. RAID 1 achieves redundancy by the simple act of replicating all data. In other words, data are mirrored between two disks. In terms of data distribution, it is same as RAID 0. Data are stripped across the disks, but for this RAID, each logical strip is mapped to two physical disks so that every disk has its own mirror. If one of the disks are failed, there will be no loss of data because the other disk will have a duplicate copy. RAID 1 performance is higher than single disk for read, but similar to single disk for write. For RAID 2, it requires 3 or more disks. This RAID uses bit level stripping, which means instead of stripping the blocks across the disks, it stripes the bits across the disks. One group of disks are used to write the data, and another group is used to write the error correction code. This RAID uses Hamming error correction code and stores the information in the redundancy disks. For RAID 3, it requires 3 or more disks. This RAID uses bit level stripping, which is the same as RAID 2. This RAID uses multiple data disks and a dedicated disk to store parity. The disks have to spin in synchronous to store and get to the data. If one of the disks fails, the data will not be lost because RAID 3 can handle a single disk failure. The failed disk will be replaced and rebuilt, and the entire contents of the failed disk will be regenerated on the new disk. Consistency of the parity must be maintained for later regeneration. RAID 3 can achieve very high data transfer rates, and the performance of RAID 3 is the highest of all other RAID.
For RAID 4, we require 3 or more disks, where one disk will be used to store parity. Let's say we use 4 disks. If a disk fails, RAID 4 can handle one disk failure. We have to replace the failed disk with a new one, and RAID 4 will use the disk content parity to rebuild the data for the failed disk. RAID 4 performance is similar to RAID 0 for read and significantly lower than single disk for write. Next is RAID 5. For RAID 5, we also require 3 or more disks. Data is striped across multiple disks along with parity. If a disk fails, we will not lose any data because RAID 5 is designed to handle a single disk failure. We only have to replace the failed disk with a new one, and then RAID 5 would use parity information from the other disk to rebuild the data on the new disk. However, in special situations where two disks will fail at the same time in a RAID 5 setup, then all data would be lost as it is not designed to handle two disk failures at the same time. In RAID 5, the equivalent size of 3 of these disks are actually used to store data, and the equivalent size of one of these disks is used to store parity. RAID 5 performance is similar to RAID 0 for read and generally lower than single disk for write. The last one, RAID 6. For RAID 6, we require 4 or more disks. Parity is spread twice on all disks. The reason of this double parity is so it can handle two disk failures at the same time. When a disk failure occurs, the recovery method is the same as RAID 5. In RAID 6, if two disks were to fail at the same time, which is pretty rare, no data would be lost. The queue parity is needed, which is used to build a simultaneous equation. All we have to do is replace the failed disk, and then RAID 6 would use the double parity from the other disk to rebuild the data on the new drives. In RAID 6, the equivalent size of 2 of these disks are actually used to store data, and the equivalent size of 2 of these disks is used to store parity. RAID 6 performance is similar to RAID 0 for read and significantly lower than RAID 5 for write.